Hello everyone, my name is Viraj and today we'll be discussing the 31st problem from the CP-31 sheet by TLE Eliminators under the 800 rated questions. Let's go. So I'll be moving on to my CP-31 sheet over here. I have ticked off my 800 rated parameter and I'll be opening my 31st problem, 2 permutations. Alright, let's read this. So you are given 3 integers n, a and b. Determine if there exist 2 permutations p and q of length n for which the following conditions hold. The length of the longest common prefix of p and q is a and the length of the longest common suffix of p and q is b. Alright, so this is the problem. Then they have explained permutation over here, but let us take this in a generalized way and see what do we mean over here. So we have been given these 3 variables, like we have been given over here n, a and b. So what is the representation when it comes to n? N is basically saying that I want basically n sized permutation. So in this, of course, the question is what's a permutation, right? What is this term? So this term is basically, when you talk about an n size permutation, we talk about basically an array, alright, made from some numbers. But when we say it's an n size permutation, we say this array will be made from numbers only from 1 to n, and all numbers, you can say all numbers will be distinct. So these are the 2 conditions which governs a permutation. Alright, this is condition 1 and you can say this is condition number 2. So if I want to represent, let's say, a 4 size permutation, what do I mean by that? I'll be using the numbers 1, 2, 3 and 4 and I want every number to come exactly once because I want numbers to be distinct. So what do I can say something like, let's say I create a permutation called 3, 2, 1 and 4. This is a permutation. Makes sense? But now if we go back in the question, what they have said is, we want to exist 2 permutations p and q of length n. So what can happen is permutations can differ also. That is, how are you calculating 2 permutations? Your question might be, maybe 3, 2, 1, 4 is the only permutation, right? But that's not the case. If you look at the conditions very carefully, all the conditions are saying to you is, you want the numbers 1 to n to come in this, and you want the numbers to be distinct. That is, every number should come exactly once. The order in which the numbers fall don't matter. So if let's say this 3, 2, 1, 4 was a possible permutation, so will be something like 4, 1, 2, 3. So will be, you can say something like, maybe something like 3, 1, 4, 1, 4, 2, something like this. And so on and so on and so on. That's why a permutation is not governed by the order of the numbers. It just wants 1 to n numbers, every number once. So this is why you have been given the variable n. We want 2 permutations p and q. Now let's go next to the next terms, that is the term a and the term b. So let's first discuss what is this a given to us. So assuming we are able to create 2 permutations p and q of the size n, what is a? Of course, these are some arrays. Imagine that I chop off some part from the very front of p and the same lengthed part from the very front of q. That is, starting from here, let's say 3 or 4 numbers from here and same amount of numbers from here. So this chopping off of a segment from the very start is called prefix. This is called prefix. Now this in itself would be some part of the array, which you can very clearly imagine, right? If I'm chopping off some numbers from the start, this is a prefix and it would be some part of the array only. And if I'm chopping off the same length from q also, what do I want to say is, these 2 parts that are chopped off should be equal, and if they are equal and their length is, let's say, whatever their length can be, I want that this longest length of such a possible chop off prefix from p and q, which is actually same or common, should have the length a. So I'll repeat this again. Longest common chopped off area from the start or longest common prefix of the length a should be created if you create or are creating some p and q permutation of the size n. This is why this a variable is given to you. Now, extending to this logic, same is why b is given to you. If you are able to create a permutation p and q, in this case, things are just the reverse order. We wanted some segment that starts from the very start and then goes to some limit. In this, we want something that starts from the back and goes to the very somewhere in the middle part of the same length again, and this is called suffix. And if you are able to find a common suffix, the longest common suffix, that is the longest chopped off area both from P and Q, which is exactly the same from the back, should have a length B. This is how you want to make P and Q. So the question now falls is, do you think you will be able to create two permutations P and Q of the size n such that their longest common prefix is A of the length A, sorry, not A, and their longest common suffix is of the length B. This is the whole argument. This is what is given to us. So if you are able to do this thing, you have to print simply a yes. And if you're not able to do this, you have to print a no. Now this is very mindful because I am not trying to print the permutation, but only I am asked whether you think such a thing is possible to print or not, else you will simply print a no. So if possible, print a yes, else print a no. Well, it's a very, very simple and easy problem. If we now come back to the problem and you give it a thought of 2 minutes, you will understand what is this longest prefix and suffix thing mean. Alright. And what we'll do is we'll actually bring up some test case also. So we have a sample case over here, that is 4, 1 and 1. Now in this case, what do I want to do is, I want a 4 size permutation. Alright. So this is basically n. So if let's say I have P over here and let's say I have Q over here, then what can happen is, I can have the numbers like this, 1, 2, 3 and 4, and then I can have 1, 3, 2 and 4. Now this is exactly what P and Q should look like. Why? Because first of all, it satisfies the condition, both of them are 4 sized. That's correct. But if I come up and ask to you what's the longest common prefix you can create, that is up till here, and what is the longest common suffix that you can create, that is up till here. So you can say this length of longest common prefix is 1, which is actually A, and this length of longest common suffix, which is 4, 4, same array up till here, because after that, you know, it's 3, 2, which doesn't match. So this is also 1, which is exactly your B number. So this such a P, Q and Q permutation formation, is giving you the right answer, is giving you a possible viable correct answer for 411 case. Hence, you would simply say the answer is yes. And if you go back to the case, of course, the answer to the 4 test cases printed yes. Alright, so this is the whole problem. Now you can pause the video, give it a 2 minutes thought, maybe try to get the idea of why and how when we can create yes and no cases. Alright, now let's start with the problem. So before we actually catch up with some idea, a very important thing to discuss is what sort of a time complexity are we targeting for. Alright, why? Because I know, like by fact, I know some things. In 1 second, I am allowed 10 power 8 elementary operations. By the fact, I know this. Now if I go back to the problem, it is written that time limit per test is 1 second. That means if I talk about one test, it basically allows me 10 power 8 operations of capacity to run into. So if I ask you, but in the problem, you were not given a test, but rather in every test, there are some test cases governed by the variable t, which is in 10 power 4 order. So if I ask you what's the number of operations you can perform for each and every test case, you simply report that to be 10 power 8 upon, you can say this is 10 power 4, which is exactly 10 power 4 operations. So you can actually perform 10 power 4 elementary operations in your particular problem. Now why is this important is, if you look at the variables given over here, A, B, N or are in 100 order. Alright, so let's just assume that N might be the most dependent factor in the complexity. Now N being in 100 order, it gives me a rough idea of what order of hundreds am I looking for in which I want to create my solution. That means if I talk about N square, will it work? Of course, because N square is 10 power 4 and 10 power 4 is of course less than equal to this 10 power 4 operations. But if I go anything higher than this, maybe in N cube complexity, it's not going to work. And if N square works, anything less than this, so on till O of 1 works. So this tells me that you are looking at some upper bound of N square order, below which you are good to go, above which you might get TLE. So even if your solution is right in a brute manner, you will start getting TLE if you cross an N square boundary. And this is what is our expected time complexity discussion. Very important, because this is helping me remove all my redundant ideas or possible ideas I could have had, which I could have spent in coding or formulating if I had not known what is my upper bound of my time complexity I want to solve this problem in. Now that I know I want to go to a limit of N square, I don't need to create ideas that might go above this. Now I can target, of course, O of N also. I can even target a constant time complexity also, but I know something below N square or something less than equal to N square. Alright, so this is our time complexity discussion, very, very important. Now let's go back to discussing our idea of the problem. Alright, so the idea is very, very simple. There is a very standard argument this problem is following. Alright, so I'll first write the argument and then we'll try to prove this. Argument is, if a plus b plus 2 is less than equal to n, or a equal to b equal to n, the answer is yes, else the answer is always no. This is the whole argument. Alright, let's try to understand this argument again. A and b are the lengths that is given to you, right? So what I'm saying is, if the sum of a, that's the length, plus b plus 2 is less than equal to n, that's the total size of the array, or if you think that the a value is equal to the b value is also equal to the n value, that's an a, b, n all are same values, then you print a yes. In all the rest cases, your answer turns out to be no. Alright, so this is the argument. Now let's try to understand this argument. Let's try to bifurcate this into like 1 and 2 cases and then this third case. So we'll talk about our first case. Where is this a plus b plus 2 sort of a logic coming from? So before we actually understand this, let's try to come up with a simple picture of what P and Q wish to look like ideally if I want to create an a-sized suffix and a-sized prefix and a-sized suffix. Let's say you want to create an a-sized suffix. So let's say up till this limit you want to create your a-sized suffix. So I'll mark this with blue. Up till this limit you want something that has a-sized. Alright. So what you can do is you can simply say, okay, the numbers I have been given are from 1 to n. If I go back over here, a and b both are less than equal to n. That means a and b fall in this limit of 1 to n. So let's say for example, let's say n would have been, I'll take an example over here. Let's say n was given 8. Now example, let's say a was given 3. So what you can do is very simply, you can place the numbers 1, 2, 3 over here and 1, 2, 3 over here. Will this not give you exactly a correct longest common prefix? Yes, this gives me of a equals to length 3, correct? Or to be very generalized way, I can report this out to be something like this. I can say, okay, if I want an a size permutation over here, I can do 1, 2, 3, 4, so on till a, and then I can do over here also 1, 2, 3, 4, so on till a. Alright, this is good to go. Now let's talk about b. Remember, b is also in this limit of 1 to n. So what can happen is, if let's say b is in that limit, I can do something like this. If this is the b limit, let's say example in this case, b was also given 3. So what I can talk about over here is, I can create something that looks like this. If I want the longest common length to look something like b, I can report it over here as, let's say I would have stopped over here as 3. Then in this case, I can start over here with 6, 7, 8. And this can also be 6, 7, 8. Or to be keeping this in a generalized manner, what can I report over here is, I can report something that looks like, you have n, then this would be n minus 1, so on, till how much limit do you want? This is n minus b plus 1, and this can be n minus b plus 1. Alright, I hope this makes sense, that from the back, all I'm doing is, I'm setting up the numbers from n minus 1 to n minus b plus 1 range in both p and q. This assures me that I totally get you can say, since like if we took an example, 8 minus 3 plus 1 would have given me 6. So like this is 8 minus 3 plus 1, this would have given of course 6. So 6, 7 and 8 would have given me last 3 numbers to be equal in both p and q, which would have created a 3-sized suffix. So this is good to go. Now comes the middle area. What do we ideally want in this case? Of course, I have created a 3-sized, or you can say an a-sized suffix over here, a-sized prefix over here, a b-sized suffix at the end, which is matching its common. So this middle area, let's mark this area, let's say with a different color, this middle area red. I of course don't want this area to match. That's my target. If this area starts matching in both p and q, it's a problem for me. So how do I make sure this area never matches? How do I make sure? Can I say a very simple thing? Let's say over here the numbers would be, of course, be, let's say a plus 1, a plus 2, so on. To this last number would be n minus b. This would be simply n minus b. Yes? So what can I simply say? If I set the numbers a plus 1 to n minus b in this range, then I can just reverse these numbers and set them like this, n minus b. 2, you can say this is dot 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 dot, this is reverse a plus 2 and a plus 1. This is the generalized method, alright. So you can imagine that what can happen is this blue area from here, what can happen is this might start growing a more to the left, a more to the right, and this red area, this yellow area can grow a bit more to the left. So this red area might shorten, in a generalized, because I have taken a generalized manner right now, but you can now imagine in your head that n is a fixed value, so n is up till this limit, right? What can happen is this A range from the start and this B range from the end can start coming a more close. And then there is of course going to be a problem, there's of course going to be some range or some part of where things are going to go a bit not useful for me, right? And this is the area that I want to identify. Then when does that happen? So now based on this idea of taking a plus 1 to n minus b and reversing that array, it makes sense to me that what can happen is, I'll take an example over here, like this example only. If let's say you took n equals to 8, a equals to 3 and b equals to 3. What you did was you created 1, 2, 3 over here, 1, 2, 3 over here, and then you in the back created 6, 7, 8 and 6, 7, 8. Now in the middle you said, okay, create 4, 5 and then create 5, 4. That's the just reverse. So this is the red region. This red region is of 2 numbers. As right now you can see it's of 2 numbers. And because it's of 2 numbers, the reverse makes sense. Try to understand this part. Let's say if you have an array of 2 numbers, that is 4 and 5, when you reverse it, this array 5 and 4 will be different than this above array. Yes? Now if let's say I have more numbers in this red range, then of course when I reverse it, this range will be different. But when is this range not different? If let's say I increase my b to be equal to 4, then what will happen is you will have to fix this 5 over here and 5 over here. Now this middle range of red region is only of one sized, in which there is only a single number. If you place a 4 over here, if you reverse now, that's still 4. So does this make sense? Did the reverse make sense? Did it create a red gap for you, which helped you bifurcate this area on the left and this area on the right, making a size prefix and b size suffix? No, right? Because now this area being so small, only giving you a buffer of one length, I'll repeat again, is now not giving you the power to do exactly what you wanted. That is, you wanted to create an a size prefix and a b size suffix. So now this buffer is a problem. This buffer went to a length of 1 and it created issue for you. Had it been of size 2 or more, it was fine. Because if we took this to be of a size of 2, you would have reversed the array and still you would have gotten that different regions in the middle of that red portion to create this bifurcation to the a prefix and b suffix. And if let's say it was of size 3, 4, so on, then still things could have looked good. But if it went to a size of 1, it doesn't make sense because now this reversing doesn't matter. That means this whole idea, generalized idea to actually run, which is the very basic idea that can strike me very directly, to place 1 to a numbers from the start, n minus b plus 1 to n numbers in the middle. This middle range should also be of the size minimum, like it can go to a minimum size of 2, cannot go below 2. That means overall, what do I want to say is, I want to say that this overall range A, this overall range B, and this middle range, which can go greater than equal to 2, assuming that right now it's the smallest range possible, that's 2, you can say that this net summation should be less than equal to n. If this net summation is not less than equal to n, then I know I will be somehow creating ranges of a and b larger, or my middle area will not be sufficient to make accurate bifurcations of prefix a length and suffix b length. This is the idea. This is why the argument 1 stands and a plus b plus 2 being less than equal to n works. Now, I have written an OR case. I hope this should be clear. You can pause the video, make some cases on your own, and you will get this idea. Alright, we do a sample case over here. So now, let's come to the OR part. OR part is saying, this is sort of a corner case, you can say, in very ideology, right? In 800 problems, it's not very common for a corner case, but as you progress along, corner cases start making more sense. So this whole idea is failing only and only at one case. That's why this OR portion. It's a corner case where what can happen is, I'll take this on a new page. Idea 2 would be, if let's say the question demands the prefix length equal to the suffix length, and that is also equal to the whole length of the array itself, then ideally the answer in this is also yes. In this case, you will argue that a plus b plus 2. If let's say a plus b plus 2 you calculate, that would be n plus n plus 2, which is of course not less than equal to n. But the answer is still yes. Why? Because this is a corner case. And how is this becoming a corner case is, for only and only this sort of a region or this sort of a case, I can just print P and Q to be exactly the same permutations. If let's say 1, 2, 3, 4, 1, 2, 3, 4. In this case, I would have a equal to 4, a b equal to 4, and of course n is 4. So n was also 4, a was also 4, and b was also 4, and voila, for this I created P and Q to be exactly same permutations, that is simply 1, 2, 3, 4, or some random permutation, just that P and Q should be same. And this will for sure guarantee you the longest common prefix to be equal to the longest common suffix to be actually equal to the whole length of the array, because now you have made both arrays common. By common sense, that makes sense. Alright, so this is sort of a corner case in the statement. And now, of course, when all these cases are exhausted, you can say my answer besides this cases would be a no part, and this no almost by intuition is coming from majorly from this first idea only, because we were able to see this if let's say by buffer ended up in a size of 1, or a increased to a very large dimension, b also increased to a very large dimension. If somewhere the total size of a, b plus 2 did not be less than equal to n, then no would start making more sense, except this corner case of yes. So third case is something I should not even discuss. It makes sense obviously if first 1 and 2 cases fails. Of course, I have to print a third case, which is simply printing no. Right, so this is the whole problem. This is a very intuitive and a very idea-based problem. It will not strike you if you don't make at least 10 cases of your own to understand what is the generalized way of representing the problem and what is the most clever way of writing my solution. When I progressed this problem and understood that I could have written till 1 to a and n minus b plus 1 to n, then this middle buffer made more sense, and then I was able to realize, okay, this is the middle length of minimized size 2, hence a net of a plus b plus 2 should be less than equal to n. And then I was able to also identify the corner case, and then the problem made sense. Alright, so this is the whole idea. Let's go to our code part now. Since you understand the problem, code is going to be very, very simple to understand. Alright, I'm just taking n, a and b over here and inputting that. So up till here, all I'm doing is taking inputs. And then I'm doing very simple checks on these two conditions. If I find a plus b plus 2 less than equal to n, or I find a, b and n all three equal, as in a equal to b and a equal to n, automatically that's equal to b equal to n, then I am printing this as yes, else I'm printing this in no. Alright, very, very simple. And now if I talk about time complexity, this is of course a constant check. All of this is a constant check to take the input also. Hence, we have achieved a very, you can say very good time complexity, that is constant time complexity, nothing better than this. Of course, this is going to work. And space is also constant, since I know all I'm doing is simply taking variables, no any other data structure to calculate my answer. Alright, so this is the whole problem, and of course very interesting problem and very observation based problem. Pause the video, drop some test cases, you will fully understand what do you mean by this prefix, suffix and permutation area, then this middle buffer strength of the length 2, and then this whole idea of yes and no will make more sense. Alright, so I hope you like the video. Thank you for watching.